Hi everyone. In the previous two videos, we have understood how to find the maximum height reached by the object and how to find the time taken by the object to reach the maximum height when it is thrown vertically upwards with some initial velocity u. Now, in this video, we'll try to find another thing for this particular situation. So let me find it. So third one, what we want to find is the total time, means from the instant it is released from the ground to the instant it reaches the ground. Okay, so the total time taken by the object, total time taken by the object to reach the ground, means once it is released from the ground, what is the time taken by the object to reach the ground again. So this is the total time taken by the object to reach the ground. Okay, in order to know that, we need to know what are the known quantities. We need to understand what are the known quantities. I am taking simply that the object is actually released from the ground with some initial velocity u. Okay, it reaches to maximum height and its velocity slowly reduces and becomes zero at maximum height. Now again the object will return back to the ground. Is it right or not? Now as the object starts at the same point and reaches the same point again, the total displacement covered by the object is zero. Taking that into consideration, I'm assuming I'm considering s value as 0. And what I want to find is the total time taken to reach the ground. Therefore, I don't know t value. I want to find that t value. Okay. And what is the acceleration due to gravity? It is minus g, as it is vertically downwards always. And what is the initial velocity? We know that the object is thrown with some initial velocity u. Now, you have information about s, we have information about a, we have information about u. What we want to find is a t. So, the kinematic equation which is helpful to find t value is s is equal to ut plus half at square. Okay, so this is the kinematic equation that we can use. Now substitute s value as 0 and you have u t as it is, and you will have minus g in place of a, so that you will get minus half g into t square. Okay, adding half gt square on both sides, you will get half gt square is equal to u into t. So 1t and 1t gets cancelled out. What you will have now, gt by 2 is equal to u. I want to find t. That's why I need to keep t on the LHS side. I need to send the remaining terms to RHS side, so that I will get t is equal to 2u by g. Okay. We call this time as time of flight. Why it is called as time of flight? Because it is the time taken by the object to reach the ground once it is released from the ground. Means it is the total time taken by the object in the air. That's why we call it as time of flight. And it is the total time taken by the object to reach the ground once it is released from the ground. Now from this time of flight, if you subtract time of ascent, means the time taken to reach the maximum height, you will get time of descent. Okay, so let me do that with a separate color. Okay, so from the time of flight, so let me consider this as a TF. From the time of flight, if you subtract time of ascent, we will get time of descent, which is the time taken by the object to reach the ground from its maximum height. Therefore, time of flight is 2u by g minus, we know time of ascent is u by g is equal to td. Now, td is equal to 2u minus u by g. Hence, it is equal to u by g. So what we can understand from this, the time taken by the object to reach the maximum height, which is the time of ascent, and the time taken by the object to reach the ground from the maximum height, which is the time of descent, both are same. Okay, so that we need to understand from this parameter. Okay, so we'll find one more parameter in our next class for this particular situation. Okay, thank you very much.